This video will include in-class 26 notes. Please feel free to stop and pause the video as it goes if you need more time. These notes start with a review of material from yesterday. So we are going to quickly go through the 4 different types of angles that we learned about are formed when a transversal intersects parallel lines. And then we will discuss what's true and solve some problems using those facts. So first up are corresponding angles. Corresponding angles yesterday were defined to be angles that are on the same side of the transversal. So they're going to be both above or both below. One of them is an interior angle, meaning that it gets trapped in between our 2 parallel lines. And the other one is an exterior angle, outside the parallel lines. So if we choose angle 7, that is an exterior angle. We would need to stay on the same side of the transversal, but over on the other parallel line, we would choose an interior angle to go with it. So angle 7 and angle 2 are corresponding angles. There are 3 other sets, angle 8 and angle 1, or below the transversal, angle 4 with angle 5, and angle 3 with angle 6. Yesterday we learned that if those lines are parallel, then corresponding angles are congruent, which for our algebra problems means they will be equal in measure. Alternate interior angles are up next. So in order to be alternate, the angles will not be on the same side of the transversal. They'll be on alternate or opposite sides, but both angles will need to be interior, so trapped in between those parallel lines. We could talk about angle 8 with angle 3 as an example of alternate interior angles, or it could be angle 2 with angle 5. Those are also congruent when lines are parallel, which means for our algebra equations, we will have those as being equal. Next up are very similar, alternate exterior, so still on alternate or opposite sides of the transversal, but both angles are exterior angles this time. So an example of an exterior angle above the transversal could be angle 1. Angle 1 and angle 6 would be an example of alternate exterior angles. The second set of those would be 7 and 4. Those, like the other 2 we've reviewed, are congruent to one another when lines are parallel. So they will be equal in our algebra problems. The last type of angle is the one that's different from the rest. These are called consecutive interior angles. They are on the same side of the transversal, like corresponding angles, but they are both interior instead of one exterior and one interior. Angle 8 and angle 2 would be an example of consecutive interior angles, or angle 3 and angle 5. They are not congruent. They are different than all of the other types of angles. Yesterday we talked about how they are supplementary. So in our algebra equations, that means that they're going to add up to be 180 degrees. Quick review of what that vocabulary word supplementary means. All right, let's jump right in and see what we can do. This problem is pretty similar to what you saw in your assignment last night, or for in-class 25. Just because we're looking for angle 1, angle 2, and angle 3's measure does not mean we need to work in that order. So what I would suggest is start with the angle that you know in the picture. I feel like angle 2 is the easiest to find because those 2 angles make this x that we're used to looking for. Those are our vertical angles. So we're going to use our vertical angles theorem back from our previous standards. And remember that that theorem tells us that those vertical angles are congruent. So angle 2 is 65 degrees. Angle 3 is probably the next best one to focus on. If I'm looking at this as a transversal that is intersecting 2 parallel lines, here's my parallel lines, that 65 degree angle that I just found for angle 2 is trapped in between those parallel lines with angle 3. They are on alternate sides, so I could call these 2 angles alternate interiors, which means if I check out my alternate interior angles theorem, I'm just going to abbreviate that, angle 2 and angle 3 should be congruent, otherwise known as equal when we're dealing with measures. That's not the only way we could figure that out though. If you had started with this 65 degree angle down here, Angle 3 is on the same side of the transversal as that angle. Angle 3 is interior, trapped between. The angle that's 65 is exterior. So these would be corresponding angles. So we could also say that the corresponding angles postulate is the reason why we know that angle 3 is equal to 65 degrees. Corresponding angles are congruent. All right, last but not least, angle 1 is up here at the top. I feel like I'm just going to use angle 3 to help me out. I see a nice linear pair rotation right there, all the way back from standard 2. Those two angles are back to back, they form a straight line, so I know that they're going to add up to be 180 degrees thanks to my linear pair theorem. All right, moving on to the problems that are more of an algebra context. So if we take a look at this next example, move my camera down a little bit, we've got a transversal here that's intersecting our two parallel lines. So as I kind of highlight those, I'm noticing that my angles that are marked are on the same side of that transversal, and they are both interior. So that means these are consecutive interior angles. If I go double check that theorem at the top in case I've forgotten, I know that those angles are going to add up to be 180 degrees because they're supplementary. We don't really have any names for the angles, so the best we can do for this statement is just to go ahead and fill in the equation we're going to use. Since they're supplementary, we know they're going to add together to be 180. I would combine some like terms and then go to work solving that equation using some subtraction first, 180 minus 72, and then you can do some division by 6 to finish that up. X is going to turn out to be 18 in that problem. Right along to the next one. Here's our transversal connecting those angles together. Check out these parallel lines. I'm seeing that those angles are on alternate sides of the transversal, 133 above, 5x plus 3 below, and they are not trapped between my parallel lines, so that means these are alternate exterior angles. If we go check out that theorem, it tells us that these two angles will be congruent. So our statement will be that 133 is equal to 5x plus 3. If we go ahead and solve that, subtraction of 3 from both sides will leave us with 130 equals 5x, and then divide both sides by 5 to get that x is equal to 26. There are a few more examples on the back, so let's go ahead and flip the page. And there are a couple of answer blanks that are missing back here. So when we look at our diagram, especially for number 3, there are actually 2 variables present. So I'm going to add an answer blank for y. We're looking for what y is equal to, but we're also looking for a postulate or a theorem to justify the equation that we write. Same thing for x. Now, although these two angles are vertical angles, it is probably not the best idea to write an equation that has both x's and y's in it. So let's try to focus on just the x to begin with. Here's our transversal. Here's our parallels. So when I look at that situation, those two angles are on the same side of the transversal, but 4x plus 32 is interior and 172 is exterior. So that tells me they are corresponding angles. That one is a postulate, not a theorem. You can check your assessment resource page. It will tell you whether it's a postulate or a theorem, but you need to remember what's true about them. So that postulate tells us that those two angles are congruent, which means we're going to set them equal to each other and then work on the algebra to solve for what x is going to be. Subtract and then divide. X will be 35. Now I could take my x and I could plug it in, figure out this angle, or since these are congruent, I could move the 172 over here, I suppose. And then I could use vertical angles theorem to say that these two are equal. but I'm going to keep practicing my new words. So if I'm looking at 6y minus 44 and 172, those are alternate angles since they're on opposite sides of this transversal, and they're not in between those parallel lines, they're exterior. So I'm going to stick with alternate exterior angles theorem, but you could also say vertical angles theorem if you wanted to. And that tells me that 6y minus 44 is equal to 172 because alternate exterior angles are congruent. This time we're going to add to both sides. So 172 plus 44 is 216. Divide by 6 on both sides, and y turns out to be 36. All right, we're almost there. Number 4. Not a whole lot happening here. We only have an x to worry about. I see a right angle box, so I'm going to fill in 90. Let's go ahead and highlight the transversal. Those angles are on alternate sides of that transversal since 90 is below and the other angle is above. And they are not interior angles. They are both exterior. So this is going to be another opportunity to use my alternate exterior angles theorem, which tells me these angles are congruent. So my equation looks like 90 equals 5x plus 30. Subtract 30 from both sides and divide by 5. X is 12. Slide down to number 5 and 6, and it looks like both of these ask us for both x and y. So let's set up a couple extra answer blanks here for our numerical answer and our reason. We don't want to focus on the x angle and the y angle together first because that will make the algebra tricky. So I'm going to go ahead and highlight this as my transversal but make it a little bit longer. Sometimes it's tricky if that transversal stops. Same thing with the parallels. I'm just going to make them a little bit longer to help this jump out at us a little bit better. So when I'm looking at the two angles that have the matching variable, the x's, they are on the same side of that transversal. They're both to the right, and they are trapped in between those parallel lines. So those angles with the x's are consecutive interior angles. Hopefully alarm bells are going off in your brain because those are the ones that are different than the others. They are not congruent. They are supplementary. So we're going to take those two angles, 5x plus 4 and 3x plus 16, and they need to add together to be 180. I always combine my like terms first. So 5x and 3x are 8x, positive 4 and positive 16 is positive 20. And then once everything's nice and combined, we're going to subtract and divide to figure out that x is equal to 20. There are a couple different ways you can find y, but they both involve taking that x value and plugging it in. If I plug it in right here, I've got a linear pair that I can use. If I plug it in down here, these angles, what is that? 3 times 20 is 60, so 76. This angle and my 4y angle are on the same side of the transversal, but this one's interior and that one's exterior. So this would be corresponding angles postulate if we used that set of angles to solve. You could have just as easily done a linear pair if you had plugged it in up here, which would have been linear pair theorem. Corresponding angles, though, are equal. So that means 76 is equal to 4y. And all I have to do to solve that is divide both sides by 4. So y is going to turn out to be 19. All right, the last one. Here's my transversal, crossing over my two parallel lines. So if I start with the x, I don't really want to think about x and y together in equation, so let's go with x and 54. Those are on alternate sides of the transversal, but they're both interior, trapped between the parallels. So that means we're thinking alternate interior angles theorem, which tells us those angles are congruent. That means 7x plus 5 equals 54. Subtract 5 from both sides and divide by 7, and x turns out to be 7. I could plug that in now and use linear pair theorem, but I'm going to stick with these two angles since I already have them. They are on the same side of the transversal, and they're both interior. So these are consecutive consecutive interior angles theorem. That's the one that's different than the others. So we're going to take these angles, and they're not congruent. They are supplementary. So add them up to be equal to 180. If we combine those like terms of -6 and +54, be careful with your signs, we'll get 12y plus 48 on this side. So then subtract 48 from both sides, we'll make 12y equal to 132. And 132 divided by 12 finishes it up, and y is 11. All right, your assignment is to do homework 26. Hopefully these examples helped.